All right, I'd like to go over homework assignment 2 because I graded them and there were a few problems that a number of people had. So I want to go over it and make sure you understand what it is and what to do to correct it. By all means, please look at the announcements in Canvas because after I'm done grading, typically I say that I'm done graded. And go and look at the comments on your own assignment. Give feedback on your grade. If my feedback is not specific enough, let me know. Keep in mind that you do have an opportunity to rework any assignment that you turn in. So I can't like spill the beans and give you the answer, like what you need to do. But I hope I give you enough information so that you know what's wrong so that you can try to figure out how to fix it. And if you can't figure out how to fix it, or if it's unclear what's wrong, by all means ask me, and I'll be glad to clarify that for you. So some of the issues in this week. Examine tuition chart. We are going to do that in a minute. Everyone needs to test more. This is 100%. This is yes, everybody. This isn't exaggeration. And finally, a few people did this. Each Java file should contain only one class. That's a pretty rule to go by, at least for the first part of this course. All right, let's look at the tuition chart. And again, unfortunately, it doesn't show up when you initially load the page. You have to click on tuition rates to see it. And here's the tuition chart. Now, I remember in the old days, they used to give people like aptitude tests to see if you were well suited for programming. And one of the things that they would do is give you and see if you had the ability to pick up patterns. And I think that this is a good opportunity for you to practice that skill because there's actually not a pattern. There's several patterns that come into play on this one. If you notice, a lot of you, in fact, most of you, got the way this part of the chart works. That is, from 1 to 12 credit hours is whatever your rate is times the number of credit hours. So 1 credit hour if you're in-county resident is 154.03. For 2 credit hours, it would be 2 times that, or 308.06. For 3 credit hours, it's 3 times, and so on all the way up to 12. That holds all the way down there to 12. And the same pattern appears for out-of-county residents and out-of-state residents. However, this is where a number of you came into difficulty. A number of you, I don't know if you just looked at that portion of the chart or were confused about what to do or whatever, but 13 through 18 credit hours, students get charged a flat amount. All right. And what is that flat amount? Well, that flat amount is 13 times their hourly rate. So 13 times 154.03 will give you this 2,239. And so on for the other 2 categories. Finally, how does this work after here? All right. Well, for 19, it's what you get charged for 13 through 18 plus another credit hour. For 20, it's what you get the flat fee for 13 through 18 plus 2 credit hours, and so on down the line. All right. So we have 3 sections of the chart. Section of the chart 1 is 1 to 12 hours. All right. And that is simply hours times rate. for 13, hard writing on this, from 13 to 18, it's hours times 13. Oh, I'm sorry. Rate times 13. Times rate. And then for 19 and above is what you got charged for 13 and above plus however many hours you are over 18. All right. So that'd be 13 times rate plus hours minus 18 times rate. All right. Now, a little math in reducing this, and if you don't believe me, do the algebra if you want. I'm not going to do it today because it's Monday. But this boils down to the number of hours that you have minus 5 times your rate. So there's 3 sections of the chart. So you need 2 sets of if statements. Well, let me rephrase that. I guess it depends how you write your if statements. You're going to have if statements that, number 1, determine the rate. And you determine the rate by looking to see if they're in county, out of county, or out of state. All right. Most of you got that part right. The part that you didn't get right is what to multiply the rate by. Most of you just took the rate times the hours. And that'll work for this, but it doesn't work for this and this. So you're going to need if statements that looks to see if the hours are less than or equal to 12, if they're greater than or equal to 13 and less than or equal to 18, and finally, if they're greater than 18. So there's 3 categories that you have to find. And you'll multiply the rate by either the number of hours, 13, or hours minus 13. Now, do this several different ways, and as long as you get the right answer, you could put this in nested if statements. You could do separate if statements, and so on. An and in an if statement looks like this. If hours greater than or equal 13, to do an and, you do 2 ampersands, and hours less than or equal to 18. So that's how you do and. You do an or with the 2 vertical lines. Now, here's a way that I would consider doing it. Really, just press this button. I wonder what it does. Really, if you think about this, tuition is hours times rate. However, there's a calculation to determine what we're going to charge for hours. So billed hours isn't the same as credit hours. So what I would do is I would write the code that looks something like this. And I'm going to write it not in full-blown Java. I'm going to write it in what we used to call in the old days pseudocode, which is false code, you know, which looks like programming language, but isn't a programming language. So I would first of all determine the rate. It's a good idea to put the comments in first. I don't do a lot of commenting in this class just to keep the code clean and because I'm here actually explaining the code. So I don't really feel the need to comment it too much, but comments are important to well-written code. So the first thing we're going to do is we're going to determine the rate. So if they're in county, rate equals 5403. If out of county, rate equals 179.21. Finally, if out of state, rate equals 330.78. So I've determined the rate. Again, that's not meant to be a full statement. You know, this is just sort of planning out the code that I'm going to write. Now I need to determine the hours billed. So if hours are less than or equal to 12, then the hours billed is simply equal to the number of hours. If the hours are between 13 and 18, and again, you can't type this in Java the way I'm typing it here now. You have to translate that into the proper Java code. Then the hours billed are equal to 13. And then finally, if hours greater than equal 19, hours billed equal hours minus 5. Now, we're going to calculate tuition. And that is simply equal to the rate times the hours billed. This is a sort of straightforward way. A lot of people have repeated some if statements. For each category, they have these if statements. And that's not wrong per se, it's just better not to repeat yourself. There's a programming adage, DRY, that stands for do not repeat yourself. So if you ever see code that's duplicate, that's a good sign that maybe you can write it more efficiently. So this is a nice, efficient way to do this. Now, this is what, you know, those of you that didn't get full credit, and if you want to revise it, this is sort of the process that you need to take for calculating tuition. Now, as far as testing goes, I didn't deduct for testing in this instance, but pay attention because there will be a point of time after I've reminded you several times that I will start deducting if you don't test adequately. How many test students would you need to run to make sure this is correct? All right. One answer you might give is you need 3, right? That's a reasonable answer. You need an in-county student, an out-of-county student, and about a state student. And that's reasonable, but it's not necessarily correct. Because really, you need, for each of these students, you need a student that is in the low credit hours range, in the medium credit hour range, and in the high credit hour range. In fact, you might want to test this with right on the border between it. So a in-county with 12 credit hours, an in-county with 13, an in-county with 18, an in-county with 19. So you'd actually have 4 for each location, and that would be a total of 12 test cases. You want to test as thoroughly as possible. When there's a bug in an application, it usually isn't something that's going to blow up every single time or give you an incorrect answer every single time. It's usually situational. In other words, under these conditions, it doesn't calculate the right value. Therefore, you want to test as comprehensively as possible all the ranges to ensure as great a degree as possible that you have the correct answer. You could actually, if you were clever, all right, you could actually write a loop that would test all of the values for this chart. Create a loop that would create a student and set the credit hours to 1, make 3 students in county, out of county, out of state, and then repeat that over and over again and actually be able to duplicate that chart. That would be like the ultimate of testing, right? Now, the nice thing about this case is you have the test results here. So if you test something and it doesn't match up with what you have here, you know that you have a mistake. Or perhaps the chart has a mistake. I guess we'll look at it, but I'm guessing that there's probably a problem with your code, because I believe this has probably been, I would hope this has been tested thoroughly. All right. So almost every software developer ever could test more. I'll just make that as a blanket statement. When I developed software, I should have tested more. All right. Everyone I worked with should have tested more. All right. It's just sort of a fact of life. So that's what we're trying to shake out in these unit tests. We're trying to make the modules that you create as ironclad as possible so that we can ensure that that piece of it works correct. And then when we take that piece and put it together with other pieces to form an application, then doesn't guarantee everything's going to work smoothly, but then we're mainly going to be focused on how the different modules communicate with each other and make sure that the modules are sending the right data and getting back the right data and things like that. All right, onward and upward. To talk today about array lists. Sort of a generic term for things that are like array lists or collections. They're a group of things. A regular variable only has one value at a time. A collection can have multiple values in it. And we've already seen an example of a collection, an array. An array is a collection. Now, there's some limitations about arrays. All right. One limitation about array is that when you make it and when you define the elements in it, you sort of freeze the size at that level. All right. So in other words, in the very first assignment, you guys created an array of strings. And maybe you put 3 or 4 things in or something along those lines. All right. So you did something like this. when we did the Mad Lib and the whole Mary Had a Little Lamb business and all that. That locks down that array to have 3 members. You can't add and you can't delete members then. It's always going to have 3. Now, a lot of cases, that's not practical. Let's think of our pizza example. In our pizza example, so the next step that we're going to take is we're going to add orders into the mix. All right? How many, and again, our restaurant only serves pizzas, so we don't need to do anything more than that. We don't need to add sandwiches or anything else. We're just going to focus on pizzas. But how many pizzas are on an order? I don't know, right? There's probably 1, right? Because that's all we sell, you know. If there isn't 1 pizza on there, they haven't made an order, right? And what's the most number of pizzas we could sell someone? I don't know. I don't know if we want to put a limit on that, right? Because what if we say we only want to sell 5 pizzas and this big spender is having a party and wants to order 6 pizzas? Well, we don't want to design our system to block it for that. So we're going to say that there is no limit. Our code is not going to enforce a limit on the number of pizzas that we put on an order. So we can't use an array for that. So what do we use instead? We use what's called an array list. Now, when we define an array list, we specify what that array list is going to contain. So we're going to have an array list of pizzas. All right. When you do your assignment with an array list, you're going to have an array list of courses. So the student's going to contain an array list of courses, because how many courses can a student take? Well, I don't know. You know, some semester they might not take any, but they could take 1 course. They could take 5 courses. Could they take more than 5? Yeah, maybe. I don't know. We're not going to limit that. So we're going to just say that they have a certain number of courses, a collection that we can expand or contract as we need to. In that case, we would say that that there's an array list in the student. We would say that there's an array list of students. Oops, that should be this. Now, with an array, we refer to an element of an array by saying array sub 4, for example. All right. How do you set the value of something in an array? We say array sub 4 equals hello. Now, we better have defined the array to have a subscript of 4. So have 5 slots in it, 0, 1, 2, 3, and 4. All right. An array list starts off, when you create a new one, it starts off as empty. So how do we add something to an array list? We use an add function. So this would add a pizza that I've named P, that would add it to my array list of pizzas. So if this is the very first one, this would become pizza 0 in the array list. We add another one, would have pizza 1, 2, 3, and so on. Now there's all kinds of things you can do in an array list. We'll look at that in a minute. But the other thing that's important is, how do we access things from an array list? And we do this. We say ArrayList.get and get the value of the position in the array. So that would get the pizza that's in slot 1 in our array list. Now, you probably should get used to reading Java, the official Java documentation that is put out by Oracle. Because it's sort of like the definition, you know, this is the specification for this language. It's not like someone giving an example or something like that. So they're kind of hard to read sometimes, but it's important that you develop a skill in reading them to figure out what you want to do. For example, how do you delete something from an array list? Well, let's look at the array list, and we'll see that array lists have multiple constructors, an empty constructor that creates an empty list with an initial capacity of 10. Now that's just an initial capacity. We can expand that if we want. .clear would remove all the elements from the list. Is empty returns if the list is empty. And remove would remove the element. And then there's some other things that we can do as well. Size returns a number of elements. So this shows you all the inherited objects, which we'll talk about inheritance in a few classes. But it also shows you all the methods that exist for an array list. With that in mind, let's look at today's example, which is where we're going to create a new class for order. And what is an order? An order is simply, you know, has a name, has a phone number, all right? Maybe some other information about the user, address if it was delivery. But other than that, it's simply a list of pizzas that they want to order, right? So if we look at order, right? What are the properties of this? A name, a phone number, and an array list of pizzas. So this says it's an array list. This said it's an array list of what? Shoot. An array list of pizzas. And what is that? It is a new array list of pizzas, and we're using the no argument construction, which exists in an array list. So this is creating an empty array list with enough room in memory to hold 10 of them. Doesn't mean that it has 10 of them right off the bat. It means there's enough memory set aside for 10 of them. Now, this is a line we haven't seen before. If you use classes that aren't like basic Java classes like string or something like that, we have to define an import at the beginning of our class to say what that object is. So we want to use array list that exists in Java util. If we didn't have this in here, it wouldn't compile because it wouldn't know what array list was, because it's not part of the base Java language. It's in another library. It's not part of the base Java library, I should say. It is part of the base Java language, but it's in a different library. So we put import at the top there. So that will allow us to use array list. When I compile in a minute here, I'm going to I'll compile without it to show you what happens so you recognize it if you forget. Then I will compile it, I'll put it back in and compile. So I have a constructor on my order that accepts two arguments, name and the phone number. And it sets those attributes. I have my set name, set phone, get phone. I have a method that adds a pizza to the array list. So this accepts as an argument a pizza object. And it adds that pizza object to the array list. Specifically, it adds it at the end of the array list. So the very first time I call this, it's going to add it in position 0. Second time, it's going to add it in position 1, position 2, and so on. Now, I want to be able to do two things on the order. I want to be able to calculate the price and the bake time. Now I'm going to assume I have a really big pizza oven, okay? So I'm going to assume that I can bake all the pizzas on an order all at once. So that's maybe not a good assumption in a real pizza place, but we're gonna play with that assumption. So the total bake time for the order is actually the maximum of any pizza's bake time, right? Because if I have 3 pizzas and 2 of them take 10 minutes and 1 of them takes 16 minutes, my total bake time is 16 minutes. The first 2 will finish after 10 minutes, and then the other one will finish 6 minutes later. So that's a total of 16 minutes. So what I have here is a loop that goes through and looks for the maximum bake time. So I set the maximum bake time to 0. I create a loop. I start I off at 0. I repeat this loop as many times as I is less than pizza size. And each time through the loop, I increment I for 1. So let's imagine there are 3 pizzas in the array list. I will start this loop out with 0. I will add 1 to I each time through, and I'll do it as long as I is less than the pizza size. What's the pizza size? I said a minute ago, there's 3 pizzas in it. So I'm going to execute once with I equal to 0. Get the first pizza on the list. I'm going to increment I is going to be 1. Is 1 less than the size, which is 3? Yes. So I repeat this again. Increment it. I is now going to equal to 2. I repeat it again. Get the last pizza from the list. I increment I again, and now I is equal to 3, which is not less than the pizza size, which is also 3. Therefore, I drop out of this loop. And what I'm doing is I'm simply grabbing each pizza off the list. So I'm pulling from the pizza array list, I'm getting sub I. So I'm getting first time through the loop, pizza 1, pizza 0. Second time through the loop, pizza 1. Third time through the loop, pizza 2. And I make this variable P equal to that pizza that I pulled from the list. I then am going to see if that pizza's bake time is greater than the bake time for the maximum so far. And if it is, then I save that as the new bake time. When I'm all done and I've checked every pizza's bake time, I'm going to have at this point the maximum of all their bake times, and that is the bake time for the order. This is the same thing for calculating price with a couple difference, with one difference. I'm not getting the maximum price, I'm adding up the price. Basic structure is the same. The basic structure to loop through array list will always basically look like this. There's a couple ways to do the syntax. This is one way to do the syntax. We're going to loop through. We're going to have a counter that starts at 0. It's going to go as long as that counter is less than the size of the array list, and you're going to increment by 1 each time through. This goes through and is going to grab pizza 0, pizza 1, and pizza 2, and it's going to add that pizza's price to the running total, and when I'm done, this price is going to have the value of pizza 1 plus pizza 2 plus pizza 3. Here's the nice thing about that. Let's say I make a change in the price of pizza. You know, the cost of pepperoni has gone up. All right, so I'm going to change the cost of pepperoni from $2 to $3. I don't have to touch the order object or the order class. All I have to do is go in here and change this number from 2 to 3. All right. This is what is known as encapsulation. Everything about an entity exists in its class. It's not like the price of pepperoni is in the order class and the price of the pizza is in the pizza class. If it has to do with the pizza, that code is in the pizza class. For the order class only has stuff about the group of pizzas. So it has the total cost, the total bake time in it. Now let's look at the unit test for this, because now our unit test needs to be bigger. All right. It needs to not just test pizzas, but it needs to test orders. So I've created one pizza here. I create a second pizza here. Keep in mind, I'm testing these things, so I'm looking at it and I'm verifying that the data is correct. I'm creating an order. I'm adding pizza 1 and I'm adding pizza 2 to the order. Then I ask, what is the cost of the order? What is the bake time of the order? Now, both of these functions go and loop through all the pizzas to get a sum of their prices. So let's compile these and run them and see what we get. I get down to the directory that my code is in, wed1/wed, see a dir, there's all my stuff, my .java, which is the source code, and the .class, which is the compiled version of it. Notice all the file names are capitalized, and all my classes are capitalized, and the names match. Unit test is capital U, capital T. Capital U, capital T in the file name. Same thing with order, same thing with pizza. And all my classes, one file per Java. So I compile this. And I can type in Java C star.java, does its thing, and it didn't display anything, so that means there's no errors. One thing that's actually kind of tough to get used to. I mean, shouldn't it like congratulate you or tell you something that you compiled correctly? No, if it doesn't say there's errors, it means it compiled correctly. Now I can run it and I can verify my results. All right. First pizza, small, thick, no pepperoni. The bake time is 16 minutes. The price is price is $9. Second one is large, thin, no pepperoni. The bake time is 10 minutes, and the price is 12. So the cost of the order is 21. Is that correct? Yes, because 12 plus 9 is 21. Bake time of the order is 16. Is that correct? Yes, because the maximum of the bake time is 16. Now we should go back and verify that that's how much these pizzas cost. All right, because if we're the owner of the pizza company, we should be able to calculate these by hand too. Remember, you can't do a program if you can't do the calculations by hand or have a chart or something to figure it out, right? That's essential to this. So you running the pizza place would know that if I ordered a small, thick crust, no pepperoni, a large, thin, and I would make sure, is this the right bake time? Hope so. Is this the right price? And then I would add the two together to get the cost and take the maximum to get the bake time. Notice I did this without making any changes to the pizza class. Pizza class is encapsulated. It has everything I need to know about a pizza in one class. So if I want to make a group of those pizzas and call it an order, I don't have to go in and change anything in the pizza class. All right. I do have to write the order to be able to process those pizzas and loop through them and so on. Now there's another syntax you can use for looping through array lists. Let me show that to you in a second. I'll actually go and I'll add this to change the order class to do this, to calculate price. I think it depends on what you learn first and all that, but this will accomplish just the same thing. I'm going to comment these lines out so I don't delete them. change the way it calculates the total, it still gives me the correct value. So this is another syntax that you can use. I am going to be a nice guy and post this to Canvas. I'll post it as an announcement. Give you motivation for reading the announcement. All right. Now I promised I'd show you what happens if you forget the import. If I forget this import up here, I go to compile it, it's going to act like it doesn't know what an array list is. It doesn't know what an array list is. That's what that's saying. Cannot find symbol array list. When you see that, there's a couple possibilities. One is that you spell the name wrong. All right. The second possibility is that it's not, you need to import the class that it's in. And that's true if you're using things that are part of the Java language. So remember the import in order to use array lists. All right, that's about all I had for today. Are there any questions either here or out in TV land? Okay. Have a good one. That's all for today. We'll either see you in lab or we'll see you next week.